All right. I'm finishing up section 9.2 using the substitution method. So now we need to solve about some of our interesting cases, like to tell whether, how can you tell whether a system is independent or dependent? Remember, independent here is it has only one solution. Has one solution. Whereas dependent has infinitely many. Okay. Or whether it's consistent, inconsistent. Consistent means it has at least one solution. Basically, it has a solution, where inconsistent means no solution. So when we were graphing, it was independent if it had two separate lines. Okay. So with graphing, to tell the difference between these two, it was, are they two separate lines, or the same line? Okay. So two separate lines of the same line. Determine whether they were consistent or inconsistent is basically inconsistent. The only type we were inconsistent was parallel lines, or they have the same slope, right? But different y-intercepts. If they have the same slope but different y-intercepts, they're parallel and therefore going to be inconsistent. Okay. And they'll be consistent if they have this going on. If there are two separate lines of the same line, then they were going to be consistent. How do you tell if you're not graphing them? Okay, so how do you tell if you're not graphing them? So that's what we're going to be talking about with these next few examples. Okay, so let's just work through them and we'll look at, these are going to be some special cases. Okay, so we're just going to solve these using substitution. So step 1 is done for this first one. Here, task 3. This right here is step 1. It is solved for y. It's solved for y. So I'll come up in here and I will replace that y. So now for step 2, over here, I'm going to take this equation, the negative 2x plus 2y equals 6, and I'm going to replace this y with this x plus 3. So this y is going to become x plus 3. So I'll end up with negative 2x plus 2 times x plus 3 equals 6. So now this new equation here is only x's, so let's solve for x. I need to distribute the 2 in. So I have negative 2x plus 2x plus 6 equals 6. Negative 2x plus 2x, if I put together like terms, that's 0. And 0 plus 6 equals 6. But the right side is also 6. So my x's end up adding out. And what I'm left with is a true statement. 6 does, in fact, equal 6, which tells me that any point that works in this one will also work in this one. Okay, if I get a true statement like that, what this means as far as the solution goes is that these two lines, they're the same line. If I was to graph them, they're going to graph the exact same line. So if they're the same line, if I get a true statement like that, that tells me it's going to be a dependent system, which means it's going to have infinitely many solutions. So for my solution, I will not write true statement. If I get something like 6 equals 6 or 0 equals 0 or x equals x, I will stop right then and be like, oh, that tells me that it's got infinitely many solutions, meaning any ordered pair that works on this first one will also work on this one. They are the exact same line. So I end up with that 6 equals 6. That tells me that I'm going to have infinitely many solutions. Okay, so there's how I can tell whether it's dependent or not. Now, what about inconsistent or consistent systems? So let's go ahead and let's do this next one. So step 1, again, I'm going to write these down. This one I actually have to solve one. 3y equals 2x. 3y equals 2x plus 3. So I think I'm going to solve trying to decide, none of these have an x or y by itself. This one has only y's and x's, no extra number. So I think I'm going to solve this one. Since y is on the left, I'm just going to solve for y. So I'm going to take this one and solve for y by dividing both sides by 3. Y equals 2/3 x. So there's my step 1. In your work, you do not have to label your steps. You can if it helps you organize your work. I do it so that if you're following along in your notes, you know where I'm at. So now we need to replace, this is what y equals, so I need to replace this y with what y is equal to. Y is equal to this, so I need to replace that y with the 2/3 x. So I will have 3 times 2/3 x equals 2x plus 3. So since there is no addition here, it's just all strictly multiplication, I don't need parentheses. I could put them, but I wouldn't distribute in this case. I would just take 3 times 2/3, which gives me 6/3 x, which 6 divided by 3, that's 2x. Now I need to move all my x's to one side, so I'm going to take this x here and subtract 2 x's from both sides. Oh, but look on this side. 2x minus 2x is 0. This is 0 equals 3. Oh, that's not true. That's a false statement. Well, in the previous, when we had a true statement, it was infinitely many solutions. Now I have a false statement. What this tells me is that there are no points that will work on here that will also work on here. There are no ordered pairs that will work in both, which tells me that it is an inconsistent system. It's an inconsistent system, which means it has no solution. Again, I would not say, oh, false. I have to say the solution, meaning since I got a false statement, it is no solution. Okay, let's go ahead and let's do this last one before we dive into a word problem. Okay, so this one, step 1's already done for me. Y equals 4x plus 4. So I'm going to replace this y with this 2x plus 4. So for step 2, I would have 2x plus 3 times y, which is 2x plus 4 equals 9. So now we distribute that 3 in. So 2x plus 6x, 3 times 2x, plus 3 times 4 is 12. 2x plus 6x, 6 is 8x, plus 12 equals 9. Let's subtract the 12 from both sides. 8x equals negative 3. Divide both sides by the 8. X equals negative 3/8. Okay, so x equals negative 3/8. So now let's go ahead and plug that back into one of my equations for step 3. Okay, so let's go ahead and let's plug that in. I think I'm going to plug it into this one, 2x plus 4, because my x is negative 3/8. So negative, oh, that's not negative. 2 times negative 3/8 plus 4. Okay, so then that gives me 2 times negative 3/8. I can grab my calculator out. 2 times negative 3/8 plus 4. I get math, enter, enter, 13/4. So there's my y. So my ordered pair, negative 3/8, 13/4. Again, this answer would be really, really hard to find graphically. Impossible almost to find graphically. So now step 4, we want to check our work. So we check it back in the original equation. Okay. So I replace, so y 13/4, does that equal 2 times negative 3/8 plus 4? So 2 times negative 3/8 plus 4 does equal 13/4. Yep, that one worked. Now the next one. So 2 times x, which is negative 3/8, plus 3 times 13/4, does that equal 9? So 2 times parentheses, negative 3/8, plus 3 times parentheses, 13/4. That does equal 9. Check. It worked. So we checked it in both. There's my solution. All right. Okay, application type problem, word problem. Here we go. So here we have, on opening night for a new play, a theater sold 639 tickets for the main floor and balcony. So this is the total number of tickets. So I'm going to just write down total number tickets is 639. So that includes the main floor plus the balcony. Okay, so basically the number of main floor tickets plus the number of balcony tickets. So we can start that equation. The number of main tickets plus the number of balcony tickets has to equal 639. Okay, so that was just me making sense of this first sentence. Okay, next, they sold $5,824 more in main floor tickets than balcony tickets. So the money made, okay, so let's make sense of that. Okay, so the money made off the main floor. So money made from main floor tickets is 5,824 more than balcony monies. Okay. So the money made on the main floor tickets is $5,824 more than the money made on the balcony tickets. How many of each type of ticket were sold? So we want to like the number of tickets. Okay. We know they say over here balcony tickets cost $17. So we know balcony tickets are, so here, this equation over here is just talking about the number of tickets. So this one's just talking, so this equation is talking about the number of tickets. Whereas this one here, which we didn't really get to an equation yet, is talking about the money made. So I know over here the balcony tickets are $17 each. And the main floor tickets right here are $24 each. So it says, write a system of equations to model the situation using given information. Use a verbal model to write each equation. So it says, let X represent the number of main floor tickets. So here, we already have the number of main floor tickets right here. So that's my X. And Y represent, so I'm reading here, and Y represent the number of balcony tickets. So the number of balcony tickets here is Y. So really we have one equation, X plus Y has to equal 639. So the number of balcony tickets is Y. Okay, so we have one equation. We want to write a system, so we need two equations. So we have some stuff over here. We haven't done anything with money yet over here, but I know the money made on the main floor tickets it's $24 each. So basically 24 times the number of main floor tickets would give me how much money is made. So basically the amount of money made on the main floor is going to equal 24 times the number of main floor tickets, which we said over here the number of main floor tickets is X. So this would be 24X. Okay. But I know the amount of those main floor tickets is, mathematically, that's equals $5,824 more than, have to add to, the balcony tickets, which balcony tickets are $17 each. So $17 times the number of balcony tickets, which is Y. So 24X equals 5. I think we have another equation. Here's my other equation. 24X equals 5,824 plus 17Y. Because I have to take my balcony tickets, add 5,824 to just equal the amount of money made on the main floor. All right, so now that I have my two equations I can solve, I'm going to use the substitution method. Okay, in this equation, this one here, we have things multiplied by our X and a Y. This one, we don't. So first, I'm going to write my two equations nice and neat here. We have 24X equals 5,824 plus 17Y. And then we have X plus Y equals, what was it, 639? I'm thinking the second equation is going to be easier to solve. I think I'm going to solve it for Y. I'm going to subtract X from both sides. So Y equals 639 minus X. So that's what y equals. So I'm going to replace this y with that. So again, replacing the y with the 639 minus x. So my new equation over here is now 24x equals 5824 plus 17 times 639 minus x. Okay, let's distribute that 17 in. I need to figure out what 639 times 17 is. 10,863 minus 17x. Let's bring the rest of it down. Okay, I'm going to add the 17x to both sides. Okay, 24 plus 17 is 1141x. We need to take this and add the 5824. Just double checking that. I'm pretty sure I had it right. Yep, now I need to divide both sides by 41. Okay, hopefully that divides evenly nice by 41. Fingers crossed. 407, it does. X equals 407. Again, don't forget what your X is standing for. Oh, sorry. Your X stood for the number of main floor tickets. So this is the number of main floor tickets. Now, to figure out my y, let's go ahead, let's plug that up in here for x. Step 4, y equals, step 3, minus 407. 639 minus 407. Oh, sorry. Oh, sorry guys. 639 232. So there's 232 balcony tickets. So we sold 232 balcony tickets, 407 main floor tickets for a total of, so let's go ahead, final step, we want to check it. Okay, so let's check it back kind of into the original. We know we should have a total of, we know total number of tickets, 407 plus 232 should be 639. 407 plus 232, yes. Total number of tickets works. And I know the main floor, so the main floor money would be 407 times the $24 times 24 is, so they basically made $9,768 on the main floor. The balcony would be the 232 times the 17, which is 3,944. And is the difference between these two, the main floor did make more money. It should have made more money. It should have made $39.44, $5,824 more. I just took these two and subtracted to make sure that the main floor made $5,824 more. Okay, so there, I think we have an answer that makes sense.